Have you ever looked up at the night sky and wondered how stars are born? Let's embark on a journey to the cosmos where the birth of a star takes place. It all begins in nebulae, colossal clouds of gas and dust scattered across the universe. Within these nebulae, there are dense pockets of matter, kind of like cosmic nurseries. Now, gravity, that invisible force that keeps our feet on the ground, is also at work in these cosmic nurseries. It pulls the particles of gas and dust together, causing them to accumulate and form a dense core. Over millions of years, this core grows larger and denser, and the pressure and temperature within it rise. This process continues until the conditions in the core are ripe for nuclear fusion, and voila, a star is born. So stars, like us, have a beginning, but they also have a middle and an end. Want to know more? Stick around. So, we know how stars are born, but what happens next? Well, after stars are born, they enter a phase known as the main sequence. This is the longest stage in a star's life cycle, where it spends the majority of its existence. You can think of this stage as a star's adult phase. So, what's going on during the main sequence? During this phase, stars are primarily fueled by the nuclear fusion of hydrogen into helium in their cores. This process releases an immense amount of energy in the form of light and heat. Yes, that's right, the light and warmth we receive from our very own sun is the result of this nuclear fusion process. But why does this process happen? Well, stars are massive. Their cores are under a lot of pressure due to the star's immense gravitational pull. This pressure is so intense that it forces hydrogen atoms to come together and fuse into helium. This is nuclear fusion. This fusion process keeps the star stable. The outward pressure generated by the fusion counteracts the inward pull of gravity. It's a delicate balance, an equilibrium, if you will. As long as there's enough hydrogen to fuel the fusion, the star remains in this stable state. Now, the amount of time a star spends in the main sequence depends on its mass. Larger stars burn through their hydrogen fuel much faster than smaller ones. So, while a massive star might only spend a few million years in the main sequence, a smaller star like our Sun can spend around 10 billion years in this phase. As the star continues to burn its hydrogen fuel, it also evolves and changes. Over time, the helium in the core builds up, and the star's outer layers expand. The star becomes brighter and hotter. Just like we grow and change, so do stars. But what happens when a star runs out of fuel? That's a great question, and it leads us to the next stage in a star's life cycle. But we'll get to that in the next scene. Until then, keep looking up and wondering about the stars. What happens when a star runs out of fuel? It expands, becoming a red giant. Now let's dive into the details. As stars consume their hydrogen fuel, they eventually reach a point where they begin to expand. This is the beginning of the red giant phase. As the star grows, it also cools down, causing its color to shift towards the red end of the spectrum, hence the name red giant. But don't be fooled by the term giant. This phase is actually quite short-lived compared to the star's entire lifespan. However, it's during this brief period that some of the most dramatic changes occur. The star's outer layers are blown away, scattering stardust throughout the universe. This dust will eventually become part of new stars, planets, even life forms. The red giant phase is a beautiful and dramatic end to a star's main sequence life. So our star has grown old and expanded. What comes next? Let's find out in the next scene. When a star has exhausted all its fuel, it faces a dramatic end. Picture the grandeur of a star burning bright for billions of years, only to face an inevitable conclusion, a supernova. This is no ordinary end, but a finale filled with such awe-inspiring spectacle that it outshines entire galaxies. But what triggers such a cosmic spectacle? Well, it all begins when the star has used up all its fuel. Without the outward pressure generated by the fusion of hydrogen into helium, the star can no longer counterbalance the intense gravitational pull of its own mass. The core of the star, now composed mostly of iron, collapses under this immense pressure. This collapse happens in a matter of seconds, shrinking the core to a fraction of its original size and increasing its density dramatically. The outer layers of the star, having nothing left to hold them up, come crashing down onto the ultra-dense core. This sudden influx of matter onto the already dense core causes a rebound effect, triggering the supernova explosion. The energy released in a supernova is so vast that for a brief period the dying star can outshine its entire home galaxy. It's a spectacle of cosmic proportions, a final brilliant testament to the star's once vibrant existence. But what happens after this fantastic display? Well, what's left behind is entirely dependent on the star's original mass. If the star was about 1.5 to 3 times the mass of our Sun, it leaves behind a dense, spinning core known as a neutron star. However, if the star was more than 3 times the mass of the Sun, the core's gravity is so strong that it collapses completely, forming a black hole, a region of space where gravity is so powerful that not even light can escape its grasp. And so our star's journey comes to an end, leaving behind a testament to its once vibrant existence. And yet, even in death, stars continue to astound us, their remnants serving as a constant reminder of the incredible processes that occur in the vast expanse of our universe. The story of a star might end with a supernova, but that's not the end of the story. It's a cycle, a beautiful, endless cosmic ballet. It all begins with a stellar nursery, a cloud of dust and gas where stars are born. They then grow, shining brightly in their main sequence for billions of years. As they age, they expand into red giants, becoming larger and cooler. Eventually, their cores collapse, leading to a spectacular supernova. But even in their explosive death, stars give life. The remnants of the supernova scatter, spreading elements across the universe. These elements, in turn, become part of new clouds of dust and gas, setting the stage for the birth of new stars. It's a cycle of birth, life, death, and rebirth. It's a testament to the enduring and ever-changing nature of the universe. So, the next time you look up at the night sky, remember, each star has a story, a life cycle, just waiting to be discovered.